All right, so this is looking at exponential versus linear growth. So first way we're going to look at it is in a chart. So here we have one chart that has x and y, and let's see what x is growing by. So from 2 to 5, that's by 3. From 5 to 8, that's by 3. From 8 to 11, that's 3. So all the x's are growing consistently. Let's see here. From y, 4 to 10, that's by 6. From 10 to 16, that's by 6. From 16 to 22, that's by 6. So because everything is going at a consistent rate of addition, that means that this one is linear. And then looking at this one over here, we have 2 to 3, so that grows by 1. From 3 to 4, that grows by 1. From 4 to 5, that grows by 1. Going from 1 to 3, that grows by 2. Going from 3 to 9, that grows by 6. Going from 9 to 27, grows by 18. So this one's not growing at a consistent addition rate, but if we look, it is all multiplied by 3. So if we were to look back through this, then we could see that instead of adding, these ones would be from 1 to 3, that's times 3. From 3 to 9, that's times 3. From 9 to 27, that's times 3. So when we're multiplying something, so this would be 3 to the n, because how many times we multiply n would be versus the x that we're on, that is going to be exponential growth. And then looking at them in graphs, we have the red line, which is linear. You can see that it is just a long straight line forever and ever and ever. It continues on and on and on and on, straight, no changes. Well, there's the change in the rise and run, but it's all consistent changes. When you look at this exponential, it starts and then it starts to go up and then it suddenly shoots up. It has this big curve and then it gets up faster and faster and higher and higher. That's what an exponential graph is going to look like. So this is what the two graphs would look like, the linear and exponential growth looking like in a graph form.